Smart services in the city. For this project, we were required to identify a design problem or opportunity within the context of the Johannesburg city in reference to one of McCullough's situational typologies and the concept of the democratic city. We were required to find solutions to the problem conceptually, utilizing pervasive computing technologies in an innovative manner. As an industrial designer and multimedia designer, we had to put our skills together to design a system to the problems or opportunities we identified. The location we chose to do our primary research was Braamfontein, an area located in the Johannesburg CBD.
We walked around Braamfontein for a short while, observing the surroundings and how people interact with the environment. We were inspired by the environment at JFF Rooftop Farm. We wanted to try to incorporate more greenery into the city in our final outcome. Another method of research we did was AEIOU observations. Our main observations were people walking to destinations, people parking their cars, pedestrians, drivers, and in terms of the environment, there was little to no greenery in the city. Our chosen typology is sheltering. The three motivational needs we identified were physical thriving, relatedness, and belongingness, pleasure, and stimulation. These motivational needs are not being met because breathing in toxic CO2 from heavy traffic can be harmful to the body and contribute to climate change. The lack of greenery makes Braamfontein uninviting, while the concrete buildings contribute to the cold atmosphere. The uninviting environment results in businesses and attractions not being as busy as they can be. We want people to feel healthy when coming into Braamfontein, to gain a sense of belonging, to feel that they don't have to rush with their time in Braamfontein, and we want people to help contribute to make Braamfontein a more inviting environment. Therefore, we need to think of ways to reduce carbon emissions for a cleaner environment, incorporate more greenery into the city to brighten up the environment, and to create an environment that will make people want to spend more time in the city.
This was our written ideation. After brainstorming different ideas, we refined our ideas and incorporated them to create a system using carbon capture technology to help decrease pollution in Braamfontein. The second part of the system would be to introduce greenhouses into the city. This sketch shows how the carbon capture technology works. The CO2 collector draws ambient air through. The CO2 molecules stick to the filter material inside the machine. Once the filter material is saturated and full of CO2, the collector is closed and heated to about 100 degrees where the CO2 unsticks. Once the CO2 unbinds from the material, it can be drawn off, leaving the filter free to collect more CO2. CO2-free air is then released. We also incorporated kinetic energy tiles where energy is generated when the tiles are stepped on.
The customer journey will be used to show how the service will be carried out. In awareness, the service can be discovered through advertising, social media, campaigns, word of mouth, or own discovery. Pre-service. Carbon will be located. Once located, it can be collected and filtered. Users will also be accepted to use the greenhouses. The CO2 will then be transported or stored. Service delivery. Carbon will be sold and or sent to the greenhouses. Greenhouse levels will be monitored and adjusted if necessary. Daily reports will be sent out to customers regarding how well their plants are doing. Post-service. Customers and retailers will have to be kept up to date. Ratings and reviews will be sent out and received. For our style guide, our main colors will be dark grey and light grey. Our secondary colors will be the blue and the green. Our icons will be minimalistic line drawings that can be easily understood. The fonts we will be using will be Ubuntu and Merit Pro as they are easy to read. Our logo is inspired by the shape of the greenhouses and the carbon capture devices. The buttons, loading bars, and scroll bars all represent and use the colors we have chosen.
We took inspiration from the Dyson air purifier as well as tunnel structures with lighting and structures that had greenery incorporated into it. These are some of the ideas we explored, and these CAD renders show our concept development where we explored ways of incorporating greenery into the structure that is connected to the carbon capture device. This is a context render showing a side view of the carbon capture device and rooftop greenhouse. This is a context render showing the outcome in an evening setting. The structure also has strip lighting that turns on during the evenings. These lights, as well as the carbon capture device, are powered by the energy generated through the kinetic energy tiles from pedestrians walking on the sidewalk. The structure has mesh in between, creating a place for plants to grow over. This is a detail of the carbon capture device. The structure was designed to be high enough to allow cars, buses, and delivery trucks to pass through. This is a context render of the rooftop greenhouse. The close-up render shows the details of the greenhouse. The greenhouse is self-sustained, so users don't have to constantly go in to check their plants. The misting system and CO2 system works on a timer and is automatically activated when needed. The greenhouse has compartments for individual users. Each compartment has a screen containing the user's information, type of plant they're growing, and the progress of the plant's growth. The screen on the outside of the greenhouse shows CO2 levels, grey water levels, and the temperature. This is a detail of how the system works. The carbon capture device collects CO2 and transports it through the structure. The CO2 is transported underground through piping and into the CO2 storage box on the sidewalk. The CO2 is then sold to companies who use CO2 to make things like dry ice and carbonated drinks. The excess CO2 is transported through piping up the building and into the greenhouse as shown in red. The blue lines show the recycled water from the building taken up to a tank on the rooftop and used in the greenhouse to water the plants.
We wanted lots of white space as the interface will be quite busy. We wanted the icons to be line drawings so they are easily understood. A mock-up of the interface is seen. The interface can be used on any device to control the carbon capture devices and greenhouses. This interface will mainly be used by the service provider. It can be controlled anywhere in the city or country. The customer will have their own interface or app where they will be able to book greenhouse space or check on how their plants are doing. The service provider, JCCA, will also be able to send customers updates and notifications through this app. This will be the final interface that will be controlled by the service provider, JCCA. This will be how the landing page will look. On the right hand side, we can see the weather, date and time display. Going down, we have the alert section. This will notify the service provider of any alerts or technical issues that may occur from any station. We then have the power settings that can be accessed, the greenhouse settings. The carbon retailers button at the bottom left hand corner of the screen allows the service provider to alert retailers when there is carbon available to buy. The main carbon levels section shows the total stored carbon throughout all the stations. And then lastly, we get the areas. The areas are where all the carbon capture devices are situated. The service provider can navigate to whatever area they desire. The service provider will then navigate to an area selected. Here it is Braamfontein, with a map showing the locations of the carbon capture devices. The service provider will then select which carbon capture device on what street they would like, and a set of controls will come up on the right. From these options, the service provider can control what they like. They can see the carbon captured, they can control the lights, and see how much stored energy there is in that device. They can even turn on and off the whole system. The open hash button will allow retailers to transfer the carbon that they have bought from the specific station. Looking at the bottom of the screen, we can see a graph that indicates the total carbon in the atmosphere and the total carbon captured per day. We will then navigate to the greenhouses. There will be a map showing the locations of each greenhouse in that area. We can then select which greenhouse we want to investigate. A screen of controls will then come up where the service provider can control the carbon levels, the temperature, and check the grey water levels of that specific greenhouse. At the bottom of the screen, the service provider can view the occupants of that greenhouse. They can view each occupant individually and send them notification if needs be.
We address the air pollution problem by designing the carbon capture device to be placed over roads where vehicles pass through. The carbon capture device releases clean CO2-free air, which creates a cleaner environment for the pedestrians walking through the city. We address the lack of greenery in the city by incorporating plants that can creep over the road structure, as well as rooftop greenhouses for residents of the city to get more involved in creating a greener community, contributing to the concept of the democratic city. Our service, the Johannesburg Carbon Capture Association, will be contributing to making Braamfontein a more inviting environment for people to be in by cleaning the air and helping the growth of plants in the city.
Our service will not only be making Braamfontein a smarter city, but also a greener one.